Alrighty. Hey gang. Welcome back, you guys. Another episode of Stove Chat. Nice to see you guys. How are you? Alright, welcome back. Good to see you guys in the chat. Love it. Oregon Coast Green Man, hello. Belgian Gulch, thank you for the email. Nice to see you. Tall Shadow, alright. Marie, hi. Happy to hear from you there in Ontario. Doug, all right, glad you're here. Thank you for the email. That's great, you guys. Glad you're all here. How is the stream? Can you see? Is everything working? My thing says I've got bad stream data going to you, but part of it I think is that I have my buffer set or my bit rate set so low. It always says that. So just let me know if you guys can see me and hear me, and if the delay's not too bad. I think it's better, you guys. I did get. We're working. Oh, okay, killer, Oregon Coast. Awesome, thank you. So we're running on cell service here now. So I spent this week, it's a struggle, you guys. I have this cellular modem, and I bought a cell prepaid chip SIM card. And man, it was a battle to get it to register on my local cell tower here, but it looks like it's working. This is the first time I'm trying it. I had to go through the settings a bunch this morning and last night and reboot the thing 100 times. So I don't know if it's going to work, but we're going to try. And if it works, you guys, this is a whole new deal because I got a speed test of like, I don't want to say like 3 and 4, whatever it is, megabits, kbps, whatever it is, up. And the fastest I was getting with my DSL was 0.3 up. So it's like, exponentially, potentially faster. So a little bit out of sync. Yeah, that's probably just from the start. So hopefully, all right, you guys, that's great. Glad to hear it. So glad you guys are here. Right on. Thanks, you guys. This is becoming a pretty cool deal. I'm really enjoying chatting with you guys about stoves. And I got a few things to dive into right off the bat here. Doug, hello, sent me a great email talking about his heater and his experiences, and he had some questions, and I'll just cover them here because they were great questions, Doug, and they're ones I get a lot. And first and foremost, actually, I just want to talk about something that Doug brought up in his email, but it's something that I've experienced many times, and I hear about it all the time in people's builds. As something that manifests, and a lot of times people are slow to identify the issue, and it's something that I've seen over and over again, and so I just wanted to talk about it really quick, and that is the presence of a lot of bare metal in a build, or a skin, as it were, that can radiate a lot of heat. People often underestimate how much of a load that puts on a system. In other words, how much heat that they can extract with bare metal in a system. And so often the reason or the way this manifests so many times in a build actually harkens back to the early days of the traditional hippie build with cob and flue pipe. And when you're building those, you'll have these big flue pipe runs, and then, your group comes in and you start to slowly cover them in cob, usually while you're burning. And what you'll find is that as long as that flue pipe is exposed, the stove runs terribly. And that's because, that flue pipe, even just a little piece of it, think of a 6-inch chimney at 29 square inches of cross-sectional area, and now amplify that over that skin of that stovepipe running through your bench, you can see you just have a whole lot of radiating surface. So it's just like rabbit ears or elephants, anything that expands the size of their skin to give them more blood vessels, surface area to bleed off heat. And so the reason I'm bringing this up, it all sounds patently obvious, and it really is, but I get this a lot. People will have a new build with exposed stovepipe, or they'll build builds like Peter's, or like what some of my early experimental builds were. And Doug, this goes right back to your question. Doug has a build that is barrels with rocks inside, something that I experimented with, probably almost 10 years ago. I posted on Donkey's board about an inside-out kind of mass idea that I had, and it's since gotten some legs. I know it wasn't I didn't invent it, but but since then Peter's built a few like that, and I have too. And And what we found, we experimented with something like that at Paul's a few times, is that you really need to limit that metal surface area or you'll never get adequate draft. And so, Doug, this is just a comment on your describing your home system to me and the way that you always need to use a bypass, and you feel, now you're 100% certain that the bypass is mandatory. And I just wanted to say, I agree. I love bypasses for starting up. But once it's masonry, it will behave far differently with regards to startup and with regards to retaining draft at the end of the system, because the metal, doesn't. It has no entrained heat, right? It's just as soon as it sheds it needs to get more. So I just wanted to bring that up because I hear that a lot, especially in new builds. People will have like a big, flue pipe run spread out, and they'll go, "Gosh, it's not working. Should we keep going?" And you really need to consider that you have so much metal there that you're losing a lot of heat, so you're losing a lot of your draft. And I think that's an important thing to think about in general with design, because I think people often oversize their metal radiators part, the metal radiator part of their system. And that's one of the things that with the tiny stove and the cook stoves that I've really come to love, is they have just a nice ratio of radiating surface to masonry mass, so you don't give up too much. So just wanted to talk about that, Doug. That was something that was really interesting to me in your email, that perhaps you weren't had picked all the way up on. As soon as even though you have a lot of mass in that build, you just have a lot of exposed skin. As soon as you get rid of a lot of that metal, it'll behave a lot differently. So exactly, Oregon Coast Green Man says heat in masonry can be lost back to the interior to maintain a temperature differential at the exhaust from the heat exchanger section. And that's exactly right. That's the thing is a masonry stove, and this actually ties back into people asking me about leaks and carbon monoxide risks in your living space, and why that's not an issue. And it's what I'm always trying to explain is that your metal box stove doesn't have any way to perpetuate draft once the fire is out. And so when you can have a situation where coals are smoldering, making carbon monoxide, and the stove box is ice cold, and so you can get CO in the space. That's really difficult to do with a masonry heater, because if you've been successfully burning the heater, then it's already warm, you'll have built-in draft, and it's always going to be pulling out. If you haven't gotten the heater warmed up successfully, then it's going to be blowing smoke out the door when you're trying to light it, and you're going to know that you're putting CO in the space. So I don't feel like they have much risk of surprising you with CO in the space. They can definitely puff back and blow stuff in your face and leak, but once you get that draft established, because the masonry can maintain that draft for hours after the fire goes out, leaks aren't an issue, and draft is much more stable. So those all metal builds, metal skins, really finicky. So I just want to touch on that. It was a little bit of a departure there. I hope that didn't go too long, but I wanted to go back. Doug had a lot of great questions in his email. Another question that he brought up, which is another one that we commonly hear about, is he asks, is there a concern about cooking, like in a cooking chamber, after a ceramic fiberboard core? In other words, is that ceramic fiberboard going to potentially somehow contaminate the food? And I'll be totally honest, you guys, I only have an opinion. I certainly have never, I'm not a scientist. I can't say definitively, but I've done a lot of research, and I've read a lot of MSDS, of material safety data sheets on a lot of different materials, because there's a lot of people who are sincerely concerned about ceramic fiberboard because of partly what they've read, partly some fear-mongering in some of the forums, and partly some realistic concerns, I think. So I just want to talk about that real quick. The issue with ceramic fiberboard from a health perspective is that it is tiny, tiny, sharp, non-organic particles that can get caught in your lungs, right? And just like silica, like asbestos, like dust, like PM 2.5 ash from wood fire. I mean, there's a whole lot of diatomaceous earth. Many materials have those properties. they're inorganic. They're not poison. They're not, the ceramic fibers are not poisonous. They're not toxic. There's no chemicals in there once you burn off the rice starch. So, my opinion is that when you are cooking in a ceramic fiberboard core, you are at risk of putting sharp dust on your food. And I maintain that you're going to get far more sharp dust on your food from just the ash and the products of combustion than you are from the CFB, depending on whether or not you're rubbing it, abrading it with the wood. But the other part of the component of that is people, I think, somehow speculate that the CFB might be wearing away or abrading away inside the combustion core, and that's not the case. In my experience, it's 100% stable inside the combustion core. The flames don't wear at it in any significant way. Now, I have seen some people's builds, like Belgian Gulch. I was going to say your real name, but I just thought I'd call you your username here. But Belgian Gulch, I know you showed me, I think you showed me, was it you? No, maybe it was someone else, but someone sent me a photo of an area on top of their riserless core that looked like it was sort of eaten away by the flames. And I'm not sure if that was his particular application, his particular product, but my experience is that my boards don't seem to be eroding at all from the flame. So Doug, you also asked, do the ceramic fiber board risers last? And my experience is they last indefinitely. Like I don't think they, short of abrasion, like physical abrasion, if you rub them with wood, they go away. But if they're just in the firebox, I think they're going to last potentially forever. I mean, within reason. I have some outside in my aluminum series. They're getting rained on, and they're fine. And I burn them, all summer, and then they sit outside all winter, and they're fine. So I think the ceramic fiberboard is really stable in its, in its form, as it were. So hopefully that helps, Doug. Hopefully that helps answer your questions in your emails. And then Belgian Gulch, thank you for that email. So Belgian Gulch sent me some great due diligence on some materials, and he's been fortunate enough to have access to these Scammel, which is a Danish refractory company that makes really interesting refractory bricks, and they make a lot of different grades. So Belgian Gulch, I don't know if you know what grade you have. I attempted, since I got your email just a few minutes ago, I attempted to go to their website and look up their data spec, data on their, I'm trying to say, look up the specifications. They have a whole host of different bricks, different ratings, and then to look up their specs, they of course don't have it like PDF online. You have to sign in and download. So I didn't get that far. So I'm not sure what their specs are, but I'm not sure why they would have deteriorated like that. So Belgian Gulch let me know that these Scammel bricks that he's been using, after just a few short burns, I think he said it looked like they went to Mars and back a few times. And I've heard that. I can't remember who. Someone else just told me that recently. They bought some Tractor Supply bricks, and when they burned and then inspected them, they were totally, just spalled and melted and all sorts of weird stuff. So I'm not sure what's going on there, Belgian Gulch. I assume that they must be one of their lower rated, higher insulative products. They have a variety, and usually the higher density, less insulative have a higher temperature rating. So you might just have been way down in their range, although it seems unlikely that we would exceed it. But obviously something happened there, right? I know it sounds strange. So I'm going to go back up here and catch up with your comments here. And yeah, Oregon Coast Green Man talking about CFB says also not highly carcinogenic like asbestos, and that's exactly right. I mean, we all know that there's risks in the dust, and I will never, shy away from that. I definitely think that it's a good idea to wear a mask, gloves when you're handling it. It's not going to kill you, but just like any time you're working with fiberglass, diatomaceous earth, cutting bricks. I mean, this is my deal, you guys. People really freak out on the CFB. I think it's the exact same risk. I consider it the same risk as working with fire bricks dried refractory mixes that are silica dust and aluminum dust, all of those things, anything dusty, particulate that can get in your lungs, they're all equal risk in my view. So CFB doesn't represent anything any more risky or any less risky than wood ash, as it were, which is why we're all trying to make cleaner stoves so we don't fill the air with wood ash. So absolutely, I want to try and minimize that, but keep in mind that our rocket stoves have, if it's a rocket mass heater, has a lot of places for the gases to stratify and lose particulate after the combustion chamber. So we're exceptionally clean compared to most box stoves in that regards. So Doug says, absolutely, it helped. Right on, Doug. Glad that worked out. And Lauren, hi, good to see you again. Glad that you're here. So Oregon Coast Green Man says, my Scan box stove is lined with Scamel board. Helps it radiate more heat out the front. The back wall has cracked and it abrades with rough wool handling. I think the riser gets too hot for the Scamel grade they used in my stove if box stove firebox temps made it crack. Yeah, that's another great point, Oregon Coast Green Man. So the flip side of that density issue, I talked about insulative bricks and the ceramic fiberboard. They rate them at densities typically, and the lower density is lighter, right? So it's more insulative, and it's almost always lower temperature rated. Well, those lower temperature, less dense materials, in my opinion, and typically, I don't think this is a blanket statement, but they typically have, they're less prone to cracking from thermal stress. So the higher you go in density, the harder these bricks get, and it seems like they become more susceptible to thermal stress. And I think the reason that is because they conduct the heat through themselves. So they can have a really hot spot here, and it starts to bleed heat through here, and you get big sort of gradients in temperature within the material itself, and so they break themselves apart. Where the insulative bricks, they only get hot on the face, but the inside stays roughly the same temperature, and it changes temperature slowly to even up throughout its core, right? So they don't break from thermal stress. That's a big problem with rocket mass heaters specifically, and high density hard stuff. And it's one of the main reasons why early on I became, not that enthused about hard fire bricks. And it's because it doesn't, many of you will have experienced this, it doesn't take very long in a rocket mass heater for your hard fire bricks to start cracking apart. Now, it's not usually the end of the heater. They'll stay kind of in the position they're in. But I find it it's counterintuitive, and it's also counterproductive, because often people will choose the hard fire bricks over a potentially superior building material simply because they feel like they're the more durable choice. And in practice, they're actually, because they're dense, they're a little more fragile, susceptible to those thermal shocks. And I started that by saying that's particularly problematic in rocket mass heaters. And I believe that's true because we go through such wide temperature swings in such short times. It's pretty unique. Most other burners don't do that. A J-tube is going to go from cold to 2,000 degrees in 15 minutes and back to cold again. And so that's a really difficult environment for a lot of these materials. So there you go. So I'm going to go back up here and catch up. So Oregon Coast Green Man says a low mass insulative surface gets far hotter against a flame source. Yeah, denser is more conductive and evenly heating. Exactly. So I think that's just it, is that it's more conductive and heating throughout it. But that means you get hot in the middle of it at this end and not at that end. And I think they break before they, just through those cycles. Whereas the insulative stuff, it's like super hot here, but it's taking a while for it to cycle through the body of it. That's probably not the best and most definitive explanation. It probably also has to do with the way the materials are stuck together. The insulative materials have a lot more give, for sure. So Always Learning, thank you, says, can you coat your insulative burn and exhaust chambers with T100 used in kilns and or something like water glass? Always Learning, this comes up all the time. And I will say to you that the answer is absolutely. You can coat them in anything you want, but the other part of that answer is I don't see any reason to. So for years, people have been talking about those things. And to me, it's it's a waste of effort and a waste of time. So it really, I mean, it depends on what we're talking about in the specific instance, but in most cases, I would much prefer just an insulative firebox like ceramic fiberboard and no reason for an ITC coating. And water glass, I don't think it offers any benefits just as like a coating. It's good mixed into some of your mortar, things like that, but painted onto a surface, it's just going to form. If it hardens up at all, it's just going to be the thinnest little eggshell over the outside. So Belgian Gulch says the Scamoles are rated at 1750 continuous. Interesting. So from a absolute standpoint, like we were talking about metals, I would probably be wary of that temperature. I would say I'm probably going to get there, right about there, probably not much more. But 1750, it's possible for sure to get there inside of a combustion core. Especially with your good fuel there, my friend. You have some hot fuel. So it wouldn't surprise me if you just had it hanging out there at 1800s. And the other part of it is probably the bigger one is the cycle, right? Is what I was just talking about, is the rate of change and the width of that difference. The delta there is just a lot for almost anything. But yeah, it's plenty for a box stove. Exactly, Oregon Coast Green Man. Plenty for a box stove. And it's funny because to say probably too low for rocket core riser is like it's hard when you do numbers, right? Because, for instance, the Robax or the ceramic glass, those are mostly rated right around like 1250 Fahrenheit sustained. I mean, I'm punishing them with more than that, I'm sure of it. But I think they can give it away so they don't actually really sustain that temp. Inside the firebox, a little bit different story. And like I said, it's probably a function of both. Just you're right at the peak of what they can handle, and then there's a really rapid cycle on there. But they're not insulative. I didn't know that. I thought they were pretty light. I think they're somewhere in between. Oh, maybe you're talking about the glass being not insulative. Yeah, right. Exactly. So the glass is not insulative. Exactly. And so even though its temperature rating is low, it can maintain sort of a stable, state somewhere within its safe range by radiating the heat away, as opposed to those Scamo bricks in the firebox. They got nowhere to go, right? There's nowhere for that heat to go. So they're just going to go 1800 degrees, 70 degrees, 1800 degrees, 70 degrees, over courses of hours, and it's tough on them. So that's my speculation, but I'm not sure if that's exactly right. But yeah, exactly. Does not get the highest temps exposed to like an insulative material. Exactly, Oregon Coast Green Man. That's right. So okay, you guys. Well, so what do you guys got? You guys got any questions? You got some anyone seen anything interesting? I went and looked just for a few minutes before we started. I did a few, I just did some poking around, and I didn't come up with anything really cool. I did a few searches for like rocket stove videos in the last month and whatnot, and I didn't see anything that I really wanted to bring up, but it was interesting, to be honest, to see that, for the most part, there's about 100 videos or more in the last month of just another kind of brick rocket stove cooker, like just sort of your standard simple cooker. And it's interesting to see those videos because they haven't changed. They're the same as the same ones that we or someone was making 10 years ago. So it's really fun seeing that stuff. So Tall Shadow asks, wondering what my take is on aircrete as a building material to make a stove core or heat riser with. That's a great question, Tall Shadow, and anyone who's been watching, if you've watched me over these last few months, you might know the answer to that already, but I'm happy to go over it because it's something. Thanks for bringing it up. So I am diametrically, I am just fundamentally opposed to the idea of aircrete anywhere in the combustion zone of a rocket stove. So about 10 years ago, kind of at the beginning of my experimenting phase, there was a whole lot of those backyard forge recipes and things like that online for aircrete type mixes. Now, they weren't usually using a foaming mix. They weren't technically aircrete, but they were basically, Portland based, usually perlite, insulative mixes. I experimented with many of those in those early days, and one constant stands out, and that is that any mixture that is made with Portland-based cement is going to fail in a rocket stove core because of what we were just talking about, because of the high temperatures and the rapid heat cycles. And I'm no chemist, so I'm going to tell you my understanding of this, and I'll probably get it wrong, but Portland cement, the bond at a molecular level is based on the hydrogen and the oxygen, the water within those materials, forming the bond to the rest, of the materials. That water will be driven out in a rocket stove, and it will turn to powder over time. So I know recently we have some new builders on the scene hyping up their aircrete. If you've watched their videos, you'll notice that they've been building stoves for about a year or maybe a little more, and I haven't seen any long-term burns. Please don't build with aircrete, or if you do, do it as an experiment and don't plan for it to last very long. I think it's a terrible, 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 terrible mix. It's neither, it's neither less polluting nor cheaper, nor, if you want to do something like that, I'm going to say just use the clay, sand, maybe some water glass, maybe a little fibers. You could still foam it. You could do all the same stuff, but just leave the Portland out. The Portland isn't going to do you any good. Yeah, Portland's hydration binding breaks down at high heat, says Oregon Coast Green Man. So that's exactly right. And so I really, Kolnitsky, yo, dude, nice to see you. So I really suggest you don't. Unless, now, let me just back that up a little bit. It is a fun, it's easy to get. It sets up hard overnight. It's fine if you want to experiment with it and do some test cores and build some stuff for your yard and have some fun making barbecues. By all means, play with it. But if you're really looking to move forward with a serious build and with longevity in mind, I would encourage you to just skip past anything with Portland in it. And it's so complex too. There's so many easier ways to accomplish that come out with much better results. So I'm really anti-aircrete. I'm really frustrated that it's been hyped so hard this past year, because now I have to spend a lot of time telling people why they shouldn't do it, and I get a lot of emails from people who have done it and it's not working for them, and they're wondering why. So thanks for asking that question. So I'm going to go back up a little bit here. And Mike. Hi, Michael. Good to see you, man. I've been thinking about you. I've been hearing you working over there. So there's Michael. You guys say hi to Michael, my neighbor. And Michael says, my kiln's soft fire brick. Speaking of which, you guys, Mike Festiva right there, he's responsible for most of my stove experiments. He gave me all of the kiln bricks that I built my first cook stove out of, from your awesome pottery experiments. They're not experiments, your pottery output. So anyways, I got distracted there. I get excited when you stop by here, Michael. Nice to see you, man. Miss you, bud. So Michael says, my kiln's soft fire brick getting up to cone 10. This is 2345. They handle this on repeated firing cycles. Right. So Michael's kiln bricks are a lot the ones like the ones you gave me, Michael, those ones that have been sitting outside and were mossy and moist. So those are super light. Those really handle the heat well. And I've experienced the same thing. The Skemmel bricks that we were talking about are somewhere in between. They're kind of dense. I experienced them out at, I think we had some pallets of those out at Paul Wheaton's on one of those workshops. And they're somewhere in between a heavy brick and an ultra light kiln brick. They're smoother. They have smaller particles. They're denser, and apparently they're more brittle as well. Because I agree, Michael, the soft ones, the soft white kiln bricks really don't crack. I mean, they crack easily in your hands, but they hold up fine to temperature. So, and Oregon Coast Green Man says if the aircrete survives long term, it just proves they're not getting up to rocket core combustion temperatures, just like interior facing metal. And I agree 100%. So, you know, you can tell with some of these builds, you'll see them and you'll go, man, these guys didn't pay any attention to any of the things that we've all learned and shared over the years. They're just kind of back there 20 years ago, thinking that smoke free means it's there. And I'm not trying to pick on them too much. There's been a lot of groundwork laid, you know, and I don't feel like there's any excuse for just kind of skipping over all of the work that's been done and just moving on to moving backwards, as it were. So, I mean, it happens. I'm not, you know, I do it too. It just is part of the learning process. But at the same time, we have a great body of work from the Aprovecho and Peter and on, you know, with the refined at least parameters to get you in the ballpark. So yeah, hooray for Mike Belgian Gulch. He's awesome. If you guys haven't checked out his videos, man, you want to see someone build some cool stuff, you check out my neighbor Michael. He's just the best. So sorry, I hope I'm not embarrassing you there, Michael. So Belgian Gulch asks, do I have a preference on using premix refractory cement versus dry mix? Yeah, definitely, Belgian Gulch. It depends on the application. But the refractory cement in the buckets, the premix stuff, it seems like it's a totally different deal than the dry bags. So the dry bags are typically made for casting. I don't know enough about the chemistry to break it down, but it seems like it's just a whole different makeup. The stuff in the tubs, sometimes it'll say castable and, you know, things like that, but it's just totally different. It's real plasticky. You know, they keep it uncured in that little thing for a long time, so that tells me that it's air cured, so that's a different process than the refractories, which, you know, are cured with I think a catalyzing refractory. I don't know, I use the wrong words, but you know what I mean. Refractory action. We'd have to go into Carl's chemistry set to really break down what's happening there. But at any rate, the bagged castable stuff is, well, first of all, it's way better, but it's also exponentially cheaper. You know, if you try and buy those wet tubs and fill a mold, you're going to spend a fortune. Whereas those 60-pound bags or 40 to 60-pound bags of castable refractory, at somewhere like Western Industrial Ceramics, they're typically, you know, $35 to $50, depending on what you're getting. And you can usually cast a whole core with a few bags. So I definitely would recommend the dry bags. The premix is really goopy and it's just good for kind of like filling little gaps. And I like to use the premix as an additive because it has a lot of sodium silicate, water glass. And so I'll add it to like my clay sands to give them some of those components. But I would never recommend using it as just a castable on its own, unless you're just making like a little small part. Then it's acceptable. So, Always Learning asks, can you discuss the thoughts on the use of various commercial refractive premixes, insulative, mid to high temp? I can talk to you about my experiences Always Learning there. I haven't, you know, so the various commercial refractories, at least up until recently, they've kind of been regional with a few national players, but they're basically just like in my materials sourcing video when I said you got to go find the suppliers to industry, you know, the people who supply the forges and the boilers and the mills. And when you find those guys, what you'll find is that they'll have a certain line of refractory, and they'll have got, you know, they'll be the distributor in that town for that line. There might be, if you're in a big industrial town, you might have, you know, E.F. Fowler and I can't remember the names right now, but, you know, you might have a few different suppliers. They'll have a few different castable lines, and within each line, they'll usually have insulative, less insulative, you know, high density, high temp, low temp, some various different forms. I haven't tried everything, but what I have tried is I've tried high densities and low densities. My preference is always going to be the low densities. They're castables that I've found. I've never found an ultra low density. Even their lowest density is usually a temperature rating of somewhere around 2,300 degrees Fahrenheit. and they give the densities in pounds, in a weight per volume, so I won't go there. But even the lower density ones tend to actually come out like as hard as the hard fire bricks. They're nowhere near as soft as a lot of the insulative brick builds that I do. So I really prefer the insulative refractories, and I fear, and I experienced it in my own. The first refractories I bought were higher density, and they were much more prone to cracking because of that issue we were talking about earlier, where we talked about the higher densities of material sort of conducting the heat through them and being more prone to cracking from heat shock than the lower density, more insulative ones. So I can't really go too in depth, but what I will say is call your refractory supplier, ask for their data sheet, look at the densities, just make sure you're somewhere, you're not looking at a 2,000 degree temperature rating, but make sure you're like 2,200 degrees or above. Even 2,100 I've done before, and that seems plenty safe. But anyways, somewhere above 2,000 degrees, you're probably safe, and kind of go for the lower density ones somewhere around that range. That's my opinion. That's what I've had the best luck with. So hopefully that helps. So, Tall Shadow, I'm glad that aircrete question helped. Good. Yeah, I kind of want to go on the warpath, but I don't want to. A few times last year I almost made a video just about that, but I didn't want to call those people out. But I do want to get that information out there because I feel like there's a lot of people getting misled right there. Just don't cast with Portland in it. So Belgian Gulch says not to cast, just cement. Yeah, so I think the tubbed cement is fine for little mortar, like adding it to clay sand or even using it by itself. But I'd add clay sand to it and thin it out. Otherwise, you're just going to end up with that same kind of brittle stuff that cracks out of there. But yeah, using it for cementing things, that's just fine. It's fine in a build. You can use it. Well, like what it's designed for, right? Like a lot of people put it around their chimney seams and things like that. And it's just fine. So, I don't hate it. It's just they're very different products, and sometimes people get confused, and they'll try and use them for the same things. So, okay, Oregon Coast Green Man gives a little chemistry there. The premix is usually based on silicate hardening, and the dry mixes are based on hydration and then sintering upon firing. I think you're right. The dry mixes are definitely based upon hydration and sintering. I think there's a small bit of refractory catalyzing going on there because they will harden before you fire them, but to really achieve the ceramic state, I think they require that firing, whereas the premix is just a sodium silicate process. I agree. So Tall Shadow asks, curious as to how the testo determines stove efficiency. How could one find out an efficiency number without a device like this? Oh man, yeah. Well, that's a really, really big question. And the short answer is there are ways to do it. There's a long history of stove builders arguing about efficiency by weighing their stoves and measuring volumes of air and weighing air. And, there's a whole lot of ways to attempt to measure efficiency without a testo, but holy cow, are they complex, and they're probably not very accurate, although you could get a pretty good ballpark, I guess. But more than anything, I don't think they're going to give you the information that really helps you tune the stove, like how many parts per million of carbon monoxide am I putting out? What is my ratio of oxygen? How close am I to stoichiometric burn? You'll never get there. All you can really do is estimate the amount of energy in the fuel, and then estimate how much you got out into the room versus how much went out the chimney. And there's ways of doing that. It's always tricky. You got volumes of air moving, you've got weights, and so the way the testo does it, to my understanding, is simple math based on the oxygen. I'm going to get this wrong, actually. I probably shouldn't even go there. But based on the levels, it measures oxygen and nitrogen and I'm not sure if it calculates carbon monoxide. At any rate, it measures a few things, and it's able to calculate the residuals in the gas profile from the stuff it can measure. And by doing that, and then included with measuring draft, it's able to evaluate what it's really evaluating. I think when they're evaluating efficiency is two things. It has temperature sensors and air sensors on the external unit, and it's also pulling from inside the chimney. So it's comparing those things, temperature in the house, temperature going out the chimney, how much air is going, how much carbon monoxide is in there, how much nitrogen, how much oxygen. And in doing all that, it can pretty much evaluate at what rate you're burning, whether you've got a lot of excess wood gas in that exhaust that could have been burnt, depending on how much fuel is left in there. So, it's always, and I think that the numbers, well, I know that my numbers are very different than Peter's numbers. We had our two testos side by side at Paul's place, and our efficiency numbers were like 5%, I think, difference. And I've called Testo and asked about that, and they use different calculations in Europe than they do here. And it has something to do with the base calculation of wood's energy output, or the base calculation for how much draft remains in the chimney, something like that. There's ways you can tweak those formulas, and so it's a real slippery slope. The numbers aren't straight comparable. You can't look at one guy's stove and go, he got an 87 and he got an 84 and that one's definitely better. It's really, 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 there's a lot of nuance to navigate. A lot. So how can one find an efficiency number without a device like that? Yeah, you're really not probably going to get there, honestly. And now these devices are becoming fairly ubiquitous. They're getting exponentially cheaper by the month. So I think that before too long, we'll start to have much more information on those things. So I'm going to go back here. Air cure and heat cure, speaking about the two refractories, says Belgian Gulch. And then Oregon Coast Greenman says Testo looks at O2, CO2, CO, and CO2, and temperature. Hard to replicate all that data. Yeah, it is. It's really hard to do anything close to that. So most of the old ways of doing it, like I said, were just measuring efficiency, and they weren't able to discern carbon monoxide and things like that. So it was really just how much energy is in the fuel by weight, and how much did we put into the room by temperature, and how much did we send out the chimney. A lot different than what we get out of Testo. I don't know how you'd ever compare those numbers. So, Augustus, thank you, my friend, man. That just means so much to me. I can't tell you how much that helps right now. I'm probably not going back to work. I've been an independent contractor building boats for the last few decades here, and I've got 4 great customers, and they mostly build like whale watching boats and tourist boats, and I've been doing their electrical design, but I'll be surprised if they still have whale watching boats to build next year. So you guys might see a lot more of me. So anyways, that really helps, Augustus. Thank you. And his question is, could a cheaper test kit that maybe only measures carbon monoxide or oxygen be useful? I don't know. I don't know enough about that. There certainly have been a lot of discussions about that, Augustus, on the various forums. There's been a few people making forays into it. There definitely are cheap Adafruit and Arduino type kits right now. You can get data loggers and thermocouples, and you can put together a pretty neat little system, and there are O2 sensors, and people make pollution devices, and so I think conceptually, yes, it's possible. I think the biggest challenge is one of practicality, and that is that it's one thing to build a little Arduino thing to test your air quality outside, but it's a whole another ball of wax, can of worms, to test active flue gases, right? That's kind of the big deal, is that these sensors are sucking in, chimney smoke it's not smoky, hopefully, because we're burning clean, but it's not easy stuff to breathe for anything. And so the sensors get, they take a beating. And even these testo sensors, which are really expensive, I can't remember. I think they're like $500 for a new CO one or something like that, but or oxygen one. I can't remember how it works out. But at any rate, they go every year or 2 years. That's why most of us are reluctant to loan these things out, because you only get so many tests before you have to spend another $1,000. I forget what the question was. Oh yeah, could a cheaper test kit be useful? So potentially, but the problem is you've got a whole lot of mechanical pumping the gases back and forth. You've got to have water traps. You've got to be able to measure within, a pretty toxic environment, and for it to last. And I think that what ends up happening is the people who have tried it have found that were able to spend a little bit of money to get a kit that conceptually works, but in practice, I don't know if you can get any real valuable testing data without high-end equipment. Now, even that testo I have is susceptible. Like if you try and use it on a new stove, it'll just plug up with condensation and it'll be done shortly. And, and like I said, just a little bit of a couple smoky burns and all of a sudden it'll start having funny readings because your sensors are dirty. So it's just, it's tough. But yeah, it'd be super useful. I think that if you could do it, if you could just test CO and oxygen, you'd for sure be getting yourself some significant data. For me, really, carbon monoxide it's not the only thing I need, but I know that if I'm down at like 0 or 10 parts per million carbon monoxide, I'm doing pretty well. Now, carbon monoxide can be diluted by excess oxygen, but still zero diluted is zero, and you can't dilute down to zero. I feel like there's value there for sure. I feel like there's value there for sure, but I don't know if it's possible to get one that's really useful in a wood burner. So, Oregon Coast Green Man, you typed a lot of stuff. I'll just kind of scan through it. Way less visible smoke. My house is warmer. Yeah, for a lot less hours. Yep, that's right. And yeah, testos will dilute to keep the sensors, but the sensor life is still really short, and that's exactly right. So that's what I was trying to say, is they have complex systems built in, and we haven't even started talking about the vacuum pump and the, it purges, has a little purge pump. And I mean, the thing is, they're pretty complicated systems. So it has to pump the gases into that thing. And then if it's got too much carbon monoxide, it'll pump fresh air in. And they're not probably going to build one. And one that just is rudimentary probably won't give you much data. So good, affordable temperature sensors and where and how to place. Kind of, a little bit again. So good, affordable temperature sensors. Well, temperature sensors, for the most part, my experience has been that they're fairly generic. There's different types. There's, K and T, and you can get on there and look at the specs. You definitely, depending on where you're going to put it, you're going to want different specs. Most of the useful data, I think, from data loggers, from temperature sensors, is going to be data on your stove, the body of the stove, how it's heating up, how it's holding the heat. The combustion core, for the most part, we've got it, tested and sorted. And temperatures inside there, they might give you some interesting info, but I don't know that you'd have any longevity in the sensors. Now, you can certainly get high temperature sensors, but I don't know that there'd be a whole lot of use. So in terms of where and how to place and where to get good ones, so I think that actually, to be honest with you, I think just cheap Amazon, Alibaba temperature sensors are fine. I don't think, because the temperature sensors themselves are just the probes with a wire. And then you're going to couple those with like your Arduino or something like that. Where and how to place, again, it's going to be super specific to each and every stove, and it depends on what you're trying to determine. I personally, at this point, I've done so much data collecting on my stove over the years that I don't have much use for temperature sensors, but for someone who was trying to, let's see, what would they be useful for? Well, they would be useful for tuning for the most part, for finding out how long it takes to get your bench hot, what hot is, because you could use those numbers to help make changes that change those parameters. Like it would change, you could change how long it takes to get your bench hot. And in doing that, it might, depending on what you did, change the exhaust, it might cool off faster, it might hold heat longer. So temperature sensors could be really useful in helping tune your stove and tune the way you use it. Like if I close a bypass after it goes out, my bench stays 100 degrees warmer for 8 hours longer. Things like that. That's really useful data. So in terms of positioning, my opinion would be you just want to identify the data you want. Is my bench warm at the end or cool at the end? Is it warm here? What's the temperature in the bell? And then I would take those temperature sensors and I would just put them either in the build, in the mortar between the bricks, or just insert them in the mortar. You can usually use a masonry bit. And they're usually just they look like barbecue probes. So you can just stick them right in, buy a long one and get it to go through the stove and into the chamber inside. And you can just you can measure efficiency and extraction and things like that. Yeah, exactly. Tall Shadow says, I see stove efficiency is more than just temperature extraction from front end to back end. Oh yeah, absolutely right, Tall Shadow. Yes. I didn't get that in your first question. It's much more than that. Yeah, there's a lot more to it. Temperature in the front end and temperature in the back end are good, but if you don't know how much wood gas you're blowing out the chimney, then you don't know how much fuel you're wasting, right? So there's multiple components there, and this is really important actually, because when we test our cores, we always, like Peter puts them in his big barrel and I build them into a stove, and we always need a stove body there to test, because there's both components of that. There's the combustion part and there's the temperature from front to back. So it's really a challenge, because you can have a great core and you can have a back end that doesn't have enough. So for instance, when I went to Washington, D.C., I wasn't able to bring much heat extraction. So I went in there and I had to explain to the test people that this is the front end for a masonry core. It burns extremely clean. You can tell by the carbon monoxide and the particulate numbers, but our efficiency is going to be rather low because our chimney temps are high, because I wasn't able to bring a masonry mass. So there's at least those two components to the efficiency. There's much more to it than just the temperatures. Yeah. So Adrian Baker, all right, thanks for coming by. Saw your video of an old Cobb J mass heater test. It seemed to be 82% efficient. How much more efficient is your tiny cook stove? Great question. So the J, I think that 80% is pretty ballpark for most J's. I think they're mostly going to be right in that range. And that's when you're really cranking on them, leaning into it, burning it as hot as you can, trying to get your oxygen down as low as you can, get as close to stoichiometric, which that word means the ideal mix of fuel and air. It's virtually impossible to reach, but ideally you'd have 0% excess air and no excess fuel going out the chimney. Those two would mix perfectly together and burn in a perfect ratio. It never happens, but that's what our aim is. So a J-tube, lots of small pieces burning super hot, the oxygen goes down. You can get pretty darn efficient at 82% or so. But the batches, both a standard Peter Vandenberg batch box and my riserless core, which is runs essentially very similar, same size firebox, they're going to be. Now again, it is going to depend on whose testo you use. So my testo shows them at about 87%. Peter's testo shows them at 92, 93%. That's the European versus the American measure. Like I said, we had our testos side by side. So on the same 8-inch 8-inch batch box that we built at Paul's, he got a 93. My testo showed an 87. So I think that the batches and the riserless core are roughly 5 to 10% more efficient than the J. Definitely, I think that the batches actually are easier to burn closer to their optimum burn rate. The J's, you kind of got to commit yourself to really small kindling for them to be burning at their best rate. When you're using bigger fuel, which is more convenient, which I usually did, so I'd have like 3 or 4 pieces in a J tube, they're not burning that efficiently, to be honest with you. The batches do a better job of kind of refocusing the heat and getting an afterburner going, and they seem to do a better job with larger format fuel that isn't just flashing off. The J's really want that flash to get their best efficiency. Augustus, you're welcome, man. Thank you for your support. I really appreciate it. So, and Oregon Coast Green Man says 2 parts at least for efficiency, combustion efficiency, and then efficiency of heat extraction section and keeping that heat in your structure. Yeah, I mean, right. There's, yeah, you can go on and on and on about efficiency. So, lots of layers there for sure. Don't believe the hype is one of my favorite things. On both sides of it, I get so frustrated when people come at me with that rocket mass heaters 10 times less wood or whatever, or however many times more efficient. You know, I'm a big believer that there's some great box stoves out there that are every bit as efficient as, you know, most rocket stoves, at least most J's. And I think that what's right for your situation is really dependent on your goals and a whole lot of variables. A rocket mass heater doesn't always win, I don't believe. So that's maybe a little bit of blasphemy, but I don't think that this narrative of box stoves, you know, rocket stoves rule, box stoves drool, I don't like it. I don't. I think most box stoves are terrible, and traditionally they've been terrible, but there's some great box stoves out there. So Hugh asks, "Hi Matt, any updates yet on your water heater?" Yes. So I did my burn yesterday, and I'm putting the video together now, and I'll hopefully have it up for you in the next day or two. It's actually exceptionally boring. I went out there to make the video, and I realized that, you know, all I can really show you is, you know, loading the wood, lighting the fire, and then I just go back every half hour, and I measure the water temp coming out, and we talk a little bit about it. But man, it is something else. I can't even tell you how enthused I am about it. I think I'm gonna have to build a little house around it or something with a radiant floor, just so I can see it, you know, circulate hot water through something and make some heat. It's unbelievable. I lit it up yesterday. Within the first half hour, I had, like, you know, the kindling burned off, and that got me 10 degrees in the water. And then I burned it for, I think, like 3 hours total. I burned maybe 12 to 15 pounds of wood, about 3 or 4 regular splits. I split them up real small so it would burn hot. But I burned it from about 8 in the morning till about 11 in the morning. That got the water temperature up to about 140 degrees, steady flow coming out. And then it was still 140 degrees like 6 or 8 hours later whenever I went back out at 5 or 6 in the evening. And and it was still just making tons of hot water. So it's really, really, really cool. I can't wait for to hear some reports of people who are building it into their systems. I've got a buddy up the hill with a new little cabin that he built for his family, and he's got radiant floors, and I'm trying to help him build one for when the power goes out. And that'd be really fun. So I'm real enthused about the water heater, Hugh. I don't have much to share. I mean, I built it pretty much as proof of concept. I don't have a whole lot of use for it here, so I'm not probably going to have much ongoing to talk about it once I sort of get it all tested. But anything you guys want to know about it, let me know. And if there's a test I can do, let me know. I'll be happy to show you how it works. So it's out there, just waiting to be used, really. So hope that answered your question, Hugh. So Augustus says, I built an outdoor stove around your 6-inch J plans and used a 30-gallon drum with internal chimney as a bell. More of the heat comes off the top than I hoped. I think I'd like to replace the drum with something more insulated to focus the heat into a bench. Any suggestions on something that might be insulated and easily moved or disassembled for a bell? Absolutely, Augustus. If you don't mind the barrel, your best bet is just to line some or all of the inside of that barrel with some super wool. That's a great solution, and it's one. And this goes back to me talking earlier about builds with metal and how much metal you have. It's great that you identified that, Augustus. A barrel is a surprisingly large radiator. It puts a ton of heat into the room, and it takes a ton of heat out of the exhaust. So you can adjust that. You could do a number of things. You could put some ceramic fiber wool or a board under the top. You could line the sides. You could do, depending on where you want the heat. Like I did one in my house that was an all metal build, and I insulated all around it except for kind of the face pointing out because I wanted it to, directionally radiate the heat, and it worked great. So that's one way to go. If you don't like the barrel, you could build with red brick, and by themselves, they do a pretty good job of kind of being a moderate in between. They definitely don't shed as much heat as the metal, so they'll push a lot more heat downstream, but they do absorb some, and then after a while, they'll start giving it back to the space. You could do some combination of those two, some brick with a small bit of metal around top, or a combination of all three of those things, lining some with ceramic fiber, like super wool, and that would be another way you can adjust those things. So hopefully that gives you some ideas. I've really adopted the use of the ceramic fiber boards as just an amazing problem solver in my builds. So I don't know how many of you guys are plan holders of mine, but in most of my plans, if there's a bell that's covered with some piece of masonry, there's almost always a piece of ceramic fiber board under there, because what that allows you to do is then you can be really cavalier with what you use for a cap, right? If you have ceramic fiber board underneath your top cap, you don't need to worry about rapid heat change and whether it's going to handle the heat. So you can go ahead and just use decorative stone. You can cast concrete tops. You could use hardy backer and tile. It opens up a whole lot of options, and that goes for the cook stoves too. I've now started, they have sort of a ceramic fiber top cover with cutouts where you want the heat to come out into the glass. And again, that just leaves you a myriad of options for then your top finish, because now you no longer are limited by, the properties of the material. The ceramic fiber board is covering that. So there's another way to do it. And then Augustus Oregon Coast Greenman has another great suggestion, which is just cob. You could just cob up the sides of that barrel until you get enough of it covered that it's starting to push more heat downstream. And that's kind of a combination solution that will act kind of like hard red bricks, and that it'll absorb some heat, but it'll still push some downstream. So, but I think moved or disassembled, I would say definitely probably just the metal. Keep the metal and line it would probably be the best. So how would you affix the super wool to the barrel? Well, there's a few ways to do that. None of them are great. So one would be like if it's inside the barrel this way, I would just make some wire hoops that sort of, compressed out against it. You could use coat hangers, bend them into, rings that were a little oversized and sort of compress them in there, and they would just be like clips that would clip that super wool to the outside. Another way you could do it is if you have access to a tack welder, you could tack weld little spikes. That's how we do it in the boats to insulate the engine rooms and building metal boats. You tack weld little nails, and then you stick the insulation on the nails, and then you can fold the ends over or crimp a little washer onto the end. So those are some thoughts on getting that stuff affixed inside of there. I think that honestly, you probably could just, on the inside of the barrel, you might be able to just kind of get it to stay in there with just a little coaxing. And then if it was the top, you'd definitely need to do some pins or something like that. You could do like a coil of something that held it up there. It might eventually deteriorate that metal, but I don't know. But those are my ideas. I don't know if they're great ones, but that's how I try and solve that. So Belgian Gulch says, I was getting 250 degrees to 300 degrees through the 1-inch CFB roof and 2.5 inches of red clay brick. Yeah, no, absolutely, Belgian Gulch. I didn't mean to imply that it won't get hot. It will. But what it won't do is it won't be 800 degrees, right? Or whatever the top of the riser is. And that's the biggest thing. So Maybe I was a little eager. I wouldn't put wood up there. But I think hardy backer and tile typically is okay. And 300 degrees is a little hot. I guess that might not make it. But you know, most stone, even a cast concrete top, because it comes through the insulation, the rate, it doesn't change really fast. So I've got concrete all over ceramic fiberboard on a few builds, and it's fine. In my opinion, my fine is maybe not the same as everyone else's fine. I'm pretty tolerant of of cracks and slop, so you know, I definitely focus more on the function. I've been trying to get better at the aesthetics, but the function is absolutely my primary goal. So, but I found that CFB with just about whatever over the top is fine. But you're right, it can get hot, and actually Belgian Gulch, that's a great data point, because what I'd like to share about that is that's kind of the temperature that most of the body, you know, that's sort of the peak temperature of red brick, honestly, that I've seen. I mean, I know you can get them hotter, but on my stoves, when I'm maxing them at their very, very, very hottest, and I've been burning, you know, it's freezing cold and I'm burning for days, the hottest I'll see, like on the tiny, around the top edge of the downdraft chamber, like the hottest spot is probably right around 250 degrees. And no problems. Doesn't seem to be an issue at all. As long as it doesn't swing real fast, it seems to be fine. So I'm going to go back up here. Oregon Coast Green Man says, my box stove is rated at 79% efficiency, but sends 300 degree Fahrenheit gases up the chimney constantly and stops heating the room within 30 minutes of fire going out. I think it combusts 80% efficiently. Exactly, Oregon Coast Green Man. I concur. So, you know, wood stoves in this country have just a couple blanket ratings. They give them like a 63 for secondary, or no, for whatever it is, 7, or maybe that's what yours is, 79. Anyways, they give you a couple ratings, but they're blowing such hot exhaust out the top. Although, you know, when I was in Washington, D.C., this is why I say there are some good box stoves. When I was in Washington, D.C., we were using the same test stoves side by side. Some of those box stoves got great numbers. They would have pretty high exhaust temps, but they'd have unbelievably low excess air and carbon monoxide, and they were efficient. You know, they were doing really well. So, you know, it's a balance of all of those factors, and some of them, I mean, there was some from Woodstock Soapstone, my favorite box stove company. They were unreal. I mean, they were running at like 250 degree chimney temps all day long. They could just kind of shut them down, and they'd get their secondaries going, and they could just kind of roll these secondaries along with the thing just kind of ticking over, really, but ticking over with clean burn, cool exhaust temps. It was really cool. I'm not going to lie. It was a cool box stove. You put literally 60 pounds of wood in that thing, and it would do that for, you know, 8 or 10 hours. So there's something to be said for that. On the other hand, 60 pounds of wood's a lot of wood. So, you know, it really depends on what your goals are. That thing would have heated an enormous house, though, much more than you could ever get with a rocket mass heater of, you know, any normal size. So, well, what else, guys? You guys got any more questions? Got any more interesting rocket stove builds or talk? I'll tell you what I'm curious about. You know what, you guys? I'm going to try really quick going over here. I want to see, you know, I just want to check up on, I'm really curious about Eric Australia on Donkey's board, and his 10-inch doesn't look like he's been back. Okay. So his 10-inch rocket, I mean, if you guys haven't been and seen the pictures of that thing, there it is. It looks like 10-inch Batch Bell. Last post was April 14th. So it's been a while since he's gotten it up there, but it's pretty darn cool, man. I can't wait to see it burn. It is an absolute behemoth. It's like 20 feet tall, and it's enormous. So that's about the coolest thing I've seen in the rocket stove world. Doug, that's hilarious. So Doug says, Matt, something's been bugging me. I thought you live in Washington. Why is your clock only an hour behind Eastern time. So, you know what? That's so funny that you brought that up, Doug. I started the stream and I said, I wonder if anyone's going to notice that clock. So that clock is one of those battery-powered, what do you call it? It's like self-updating to the atomic clock in Denver kind of deal. And once every, I don't know, few months it seems like, I wake up and it's just totally wrong. Like it'll just have done something overnight and just completely screwed itself up. And then you just wait like a day or two. I was actually wondering if it was going to do it. Oh, I clicked on the wrong thing. I'm downloading some big pictures there. I was wondering if it was going to do it while I stream, but at some point today I'm going to look up there and it's going to be just spinning around really fast, self-correcting. So I didn't do it. I didn't set it on that time. I am on West Coast time. That clock is 2 hours fast. So hopefully it's going to fix itself before too long. Yeah, I woke up this morning and I looked at it and I went, oh my God. But then I figured it out. I was like, there's no way it's whatever I thought it was, 7. I think I got up at 5. So yeah, no, it's broken. Oh, like much of my life, huh? So, how are you guys doing in quarantine? Everyone doing okay out there? You guys getting enough food and staying positive? I hope so. I've been having a pretty good run here. My little town is not too badly affected, and I've got plenty of food, so I'm not too put out. But I hope you guys are all doing okay. And Pete, nice to see you. Yeah, my clock is all screwed up. So what else, you guys? Any other questions? You can ask about my clock or my rings or whatever you want. I don't care. But I think if no one's... we've been going for over an hour now, so maybe we'll wind it down before too much longer here. Although I'm happy to stick around if you guys got something to chat about. So, yeah, maybe we'll wind her down. Yeah, you're welcome, Belgian Gulch. Thank you, man. Thank you guys for being here. I really, really appreciate it. It's fun to talk about this stuff, and it's great having you guys here. Tall Shadow, really appreciate you, man. Thanks for all your hard work in this space and communicating with me, and Belgian Gulch as well. Pete, I'm in Port Angeles, Washington. I'm right across. I can actually see Victoria, British Columbia out my window. So I'm closer to Canada than I am to any American cities. I'm about 2 hours from Seattle, a little more, and I'm west of Seattle. And I'm just only 17 miles from Victoria, British Columbia. So I live in the far northwest corner, continental United States. I live kind of right behind me is Olympic National Park, 6,000 foot mountains, and right down below me is a great surf break in the Strait of Juan de Fuca. So I moved here because I got surf and mountains within 10 minutes, and that's it. Get to live on a farm, away from the city, out in the woods. So, Hugh, if you want to ask right now, you're welcome to. If you feel like it, or you can email me either way, whatever you'd like to do. David Swanson, good to see you. You're welcome, man. Thank you for coming by. Really, really appreciate you guys. So, I'll stick around for just a minute more here. Life is good. Glad to hear it, Belgian Gulch. It's pretty good here too, man. Pretty good here too. I actually feel I'm sort of happy to be told to stay home. I don't feel bad about not going and doing stuff. I like home. I've been getting a lot done on in my shop, working on my cars and things like that. So it's been good. So, all right, you guys. Well, I think I'll wrap it up. Hugh, do email me. I'll be happy to answer your questions. And all you guys, thank you so much for coming. Let's do it again next week, huh? I'm really enjoying it. So tell your friends, think of some questions, send me emails, photos, videos. I think, so this went pretty well with the stream, you guys. I think my internet is fast enough. I might be able to start showing videos and stuff. So email me some stuff. We'll try. And maybe next week I'll have a special guest on. I'm going to try and get my buddy Manny the Sea Cow on the phone again, and we can talk about his cool cooking build. So, and I'm going to read just a couple more comments. Rick, you're welcome. Rick says, thanks, Matt. These are really great, informative, and casual. You're very welcome, Rick. Thank you for being here, man, and you stay safe and we'll see you next week for sure. And Pete says, turned your riser list into the ultimate pizza oven. Design is almost finished. Thanks to Corona, you were able to work on it. That's awesome, Pete. So Pete sent me some great pictures from his original pizza oven built on my riserless core that he did. He built it in Belgium, I'm pretty sure, and he did a really cool thing that I hadn't really thought of, the way he kind of wrapped the exhaust around, and it's really neat. So Pete, I'm really looking forward to seeing that, and when you get it done, send me pics and we'll share it on the stream if you want, or put up a video and we'll chat about it. I think it's really, really cool. And as well, I've been chatting with a fella in Australia, Adrian, I believe his name is, and he sent me a drawing of his kind of metal bake oven cook stove design that he's building around my riserless core. And again, it's really, really cool. So I want to share it with you guys if he'll let me. So I'm really excited to see those come to life. And I have a metal riserless core design that I designed a year or two ago, and I haven't built it, and I probably won't now that I don't have any income for a while. So but I would like to build a metal one. So I'm curious about yours, Pete. I'd like to see it. So Marie, I'm glad your questions were answered. Thanks for coming by. Augustus, really appreciate you being here, man. Thanks for all your support and for the great questions. And you guys are all very welcome, man. I really like doing this. So we'll do it again next week, and I think that's enough for now. So I'm going to hit you with the closing video and sign off. And hey, I hope you guys have a really good day. Stay safe, and I'll check in with you guys next week. I'm loving this new internet, so we'll just keep building this thing up. All right, you guys. Let's see if I can find my thing here. Alrighty. Take care, you guys. See you soon.